So today we'll go ahead and talk about descriptive statistics, and I'm going to use an example in Visual Studio Code, and I'm going to be using a Jupyter notebook, and the code I'll be working with practically is Python, okay? So I go ahead and set up my notebook. Note that I have saved it within the same folder as I have my data set that I'm going to be illustrating in this example. So the different types we can talk about are central tendency and variability. So the first thing I want to do is get a cell for Python in which I'm going to write a comment for myself. In this cell, I would like to first import the libraries that I need, okay? So I will need pandas, for instance, and I'm going to shorten it to PD. I will need PD. It's doing that on my, okay. I will also import NumPy, and I'll shorten it as NP. So I can go ahead and run this code. And once I click the play button, it asks for which Python environment I'm within. I have the later version 3.12.0. I go ahead and run that. So that takes a few seconds to run. And these libraries will help me import the data set, but also are libraries for Python or external libraries that I can help to do some of the analyses, okay? So I'm using a data set that we have worked with before, Elon's data set. I'm going to go ahead and import the data set. And how I do that is I call up my library pandas, but now it's shortened as PD, and then dot and ask that it read in a file. So I have to be certain about the extension of that file. I know that it's a CSV, so I call up CSV, use parentheses and quotation marks, and start to write the name of the particular data set. Notice that it comes up in the dropdown because I'm within the right folder. Once I execute that, okay, I get the display of the data set itself. And this means that I get to see the first top 5 rows and the top bottom 5 rows of it. It's letting me know in total it has 614 rows and 13 columns, okay? Now, this wouldn't be ideal because that would imply every time I do an analysis, I have to pull up this entire data set with this extension. So I'd rather turn it into a pandas data frame, okay? So import the data set as a pandas data frame. And I'm going to call it data, okay? So that is the name of my new data frame. I then go ahead to write the very same code that I had at the top. And I'm looking for this particular data frame. Notice that I get no output, okay? And this is because I've not asked to view the particular data frame, right? So to get to view it, I just call up its name, which is data, and which is how we will do most of the analysis. We'll call up data, and then we can go into looking at the particular descriptive statistics. So I want to get some more information about this data set, okay? I could call up data.info, okay? Now this will generate results that will show me what other contents within the particular data frame, including the columns and the number of samples in there. So it tells me that this is a pandas data frame and it has 614 entries or samples. And it also has a total of 13 columns of variables, okay, starting over here at loan ID, ending at the loan status. Now I get to see the non-null count which would imply how many samples there are for each of these variables. You'll notice that they're varying, and yet the total number is 614. Some of these have 599, meaning they do have some missing bits of information, right? So let's go ahead and look at these particular descriptive statistics, okay? To generally call up a whole array of different descriptive statistics, okay? I would use data.describe with the brackets in there. Okay, so notice that in this instance, it generates for me different bits of information, okay? And it only notices or generates these for the numerical variables within the data set. For instance, these types of variables that have things like integer and float in terms of their data type. It does not give me results for the objects, which would be a string data or categorical data, okay? Now here I have information like the counts. This would be the number of samples in there, the mean, which is the average. We also have a standard deviation, the minimum value, okay? The 25th percentile or a quarter point of the data set, the middle point or median of the data set, all the way to the maximum, okay? So if, for instance, we had to specifically look at, say, the mean and the median itself, okay, and compare these two to each other. And let's start off with the variable applicant income. We see that its mean is about this, okay? And its median is a value that's much lower, right? What does this tell us about this particular value? Okay, the mean is greater than the median. So already we know that in central tendencies that we look at and looking at the distribution of a data set, the mean and median talk about whether a data set or a variable is normally distributed, okay? So when it is normally distributed, we expect that these values should be close to each other or exactly the same. But in this instance, we can see the median is much, much lower. So what this lets us know is that we have a positive skewedness, all right? And how would we continue to communicate that in a manner that is palatable to a wider audience, okay? So we know statistically it's not normally distributed, but what would it imply in terms of interpreting this particular result, okay? So this could mean that there's a limit on the minimum value or minimum amount an applicant income should be, but no limit on the maximum amount, okay? So this is how the Sandra situation can be interpreted when we're looking at a situation of that manner, okay? So we're going to go ahead and look at, for instance, a specific, if you want to look at this descriptive statistics of a specific variable, you would call up your data frame, and then in the parentheses, okay, use quotation marks and call up any particular variable that you want to look at. Okay, let's look at ooh, okay, let's put those incorrectly. Right. Sorry, I wasn't supposed to put the dot. That's what confused it. Right, so I get the parentheses, and then notice it will give me various variables that I can look at. So let's look at loan amount, for instance. And I just want to look at the descriptive statistics of the loan. So here's our display. We have, if we're looking at our mean, it's 146 and our median is 128. So again, we have a similar situation to what we have been seeing. We also have some other aspects, okay? We have the count that is showing us the number of samples of 592. So we know that this particular variable has some missing values in it. And one has to go ahead and deal with that before when you are reprocessing the data set, okay? We also have our range, which would be our maximum versus minus our minimum. So that's another aspect we can look at, okay? But if we want to look at the descriptive statistics of the categorical variables or the string data that we have in there or object data, we'll call up data. Let's say I specifically want to look at only the one variable. Okay, we have, for instance, in here, education. And then we can pull that up, describe it. So this generates a different kind of number of pieces of information. It will show us the count, okay, the total count of samples. It will show us how many unique categories there are, and it will show us the most top or the category that has the most frequency or appears the most within that very variable education. And in this case, it is graduate. And then it will show us how many times it occurs, right? Let's look at, if you wanted to specifically get those central tendencies without using the describe, you can just specifically ask for the particular variable. And call up perhaps mean or median, and then you could run that and get your result, okay? Or even mode, okay? Let's look at some of the distribution measures, okay? So we can have a measure like, for instance, kurtosis, okay? Forgot to put the hashtag kurtosis. Now, this kind of measure would talk about the distribution of the data, okay? It would talk about whether it is skewed or not, okay? And those values are based on thresholds that are already given beforehand or that are statistically known. So to calculate our kurtosis, okay, so this measure will look at distribution of our data points. Okay, so to look at it, let's, for instance, look at the kurtosis of a particular variable. I want to look at the loan amount again. And call up the analysis kurtosis, which immediately appears, and run that. So I have here a value that is saying 10 plus, or a positive 10.40. What does this value talk about? Okay. So we can have different types of kurtosis, okay? We can have where there is an excessive positive or negative kurtosis, and the levels are also varying in terms of whether it's low or it's medium, okay? For instance, a normal distribution would have a kurtosis of about 3, okay? And okay. If there was normal distribution, but in this case, we have 10, which is way above. So we have a positive kurtosis. Okay. And we want to see how this would affect what we are looking at. Okay, how would we communicate it in terms of the outlay? Okay, so about 3 would be a moderate. Okay, if it's much higher, like much higher than 3, then it's positive, then it is a positive kurtosis in our scenario for the loan amount. Okay. We can also look at the skewedness of our data set. Right. Or particularly even the variable. And that's also a test that we would do in a similar fashion. So we're looking at the loan amount again. And we just want the skew. Again, this is a measure that talks about the distribution of that data. So we have a skewedness of about 2.6. So we can clearly see that this is a positively skewed variable. And again, we saw this when we are looking at the mean and median. So they very easily allude to that, but we confirm it with the skewedness and other parameters in the descriptive statistics. So I will stop here for now, and then we can follow it up later.